Happy Friday, everyone. I'm Brady Volpe, founder of the VolpeFirm and Chief Product Officer at OpenVault. Today, we're diving deep into a topic that's at the heart of our digital lives, DOCSIS 3.1, and understanding how to estimate OFDM and OFDMA capacity. It's really all about unlocking the potential of our broadband networks and ensuring we're ready for the upcoming data demands of today's networks. And who better to explore this topic with than a true maestro of the cable industry, a consultant who's seen the evolution of DOCSIS from its early days to the powerhouse it is now. He's a man who can explain complex technical concepts with ease, making even the most intricate details of DOCSIS 3.1 accessible to all. Please welcome the one, the only John, don't touch my new do, Downey.
Thanks. This is 25 years I've been shaving my head, and I said, you know what? I'm going to grow it out to see if I have hair. I think it's been dormant all this time, so it's coming in pretty good.
It's looking awesome, John. It's good to see that big head of hair on you. I'm a little jealous myself. But it's good to see you on the show. Welcome back, John. So today we are going to talk about OFDM and OFDMA, like how do we figure out how much capacity is going to be going down through that pipe. Before we get into that, I want to talk about something I saw in the headlines yesterday, Pi Day, March 14, 3.14, which was a new rule that the FCC put into place. So the FCC's passed new rules that will require all cable and satellite TV providers to clearly disclose the all-in price of subscription and promotional materials. So this is really just a sort of a PSA for all cable operators out there. I imagine all the large cable operators have already heard this coming down the line, but if you're a smaller cable operator, make sure that you're disclosing all the hidden pricing information out there. I really don't think this is a big issue in our industry, but if there are anything that's not being disclosed when you're promoting your pricing and things out there, FCC is going to be keeping an eye on that and make sure we are communicating all pricing for our, basically what we're putting out to our consumers. Would love to hear from people, drop in the chat or drop in the comments below what you think about this new regulation, and also be interested in hearing from our, even from our regular subscriber listeners, what they think about this, because my perception is not a big deal in our industry. This is a lot more impactful. Like, we should be definitely doing this for like the airline industry that has a lot of hidden pricing and stuff like that. I just don't see this being that big on our industry. John, your thoughts?
Even mobile and cell phone,
Yes, definitely. My cell phone is so much higher than what I actually think the actual pricing is.
Yeah. I mean, you got taxes. Like, even, I think everyone here would agree, we're all consumers too.
Yes.
So we don't want to have like surprises. I want to know what the price really is. Taxes included. If I have an extra set-top box, am I leasing it? I might not even know I'm leasing it.
Right.
So it shows up later on.
The cost difference even maybe between HD and non-HD content. Just make that really clear. That we should know what we're paying for. I think that's a reasonable thing to ask for.
It's like bait and hook, right? Or is that what it's called?
Bait and switch.
Bait and switch. Bait and hook.
Yes. Bait and hook is when you're out fishing, I think.
Yeah. Cut bait or fish or cut bait.
Okay, we're going to stop with the analogies now. I think we're crushing it.
But yeah, you're right. It's like I lead you in with a lower price. I get you to sign up, and then you're locked in for, say, a year, and then you have a higher price.
So FCC is going to be watching now. So we gotta tighten that up and make sure everyone is lots of transparency. So here we are. We're going to be talking more about DOCSIS 3.1 today again. And people are like, hey, why don't you talk more about DOCSIS 4.0? DOCSIS 4.0 I think it's going to get pushed out a little bit more. There's things going on with chips and stuff. There are a telecompter came out, a telecompetitor, sorry if I'm pronouncing their name wrong. They came out with a couple of press releases. I think this was last week. One is talking about Midco. Midco Communications may skip DOCSIS 4.0 altogether thanks to DOCSIS 3.1 extended, or as we like to say, we'll say DOCSIS 3.1 or DOCSIS Pi, since yesterday was Pi Day. And then there was a second one, the article to the right, is DOCSIS 3.1 Plus, which is another way of talking about DOCSIS 3.1 extended, just for small cable operators, or will the big guys use it too? And I extracted two sections out of these articles that I thought were particularly important, which was really driving these articles. One was where Charter was really talking about, we're going all DOCSIS 4.0, we're in on DOCSIS 4.0, and then they kind of have taken a step back, and specifically from this article, it says it looks like Charter is planning to deploy DOCSIS 3.1 Plus, or DOCSIS 3.1 Extended, quite broadly based on what the company outlined for Phase 2 of the 3-year network investment plans it announced 15 months ago. So Charter's really changed their strategy now. Rather than going heavy on DOCSIS 4, they're going to go heavy on DOCSIS 3.1 Plus, adding those extra OFDM and OFDMA channels to give them that extra runway to just keep on going with it. And then the other aspect, or the other extract I pulled out of this, was DOCSIS 3.1 Plus, also known as DOCSIS 3.1 Extended, will allow the smaller providers to compete without a huge capital outlay, that huge capital outlay being DOCSIS 4.0. In some cases, it will be the last flavor of DOCSIS they use, meaning a lot of these smaller operators probably will never move to DOCSIS 4.0, according to Telecompetitor. So, John, thoughts on that? It's a pretty interesting change of events here.
But I think we've been kind of preaching this. I mean,
Yes.
Let's exploit 3.1 as far as we can. And we said it 2-3 years ago when we came out and said, hey, why don't we call it Pi? Because it's 3.1. What's next after 3.1? 3.1 plus, 3.1 4. We said, yeah, Pi. Here we go. Math guys, right? We just wanted something with more downstream capacity. If I can reclaim downstream spectrum by getting rid of analog channels and maybe even converting MPEG-2 digital channels to MPEG-4 over IP video, I can shrink that spectrum use down, open up some spectrum, and then just do more OFDM.
Right.
You mentioned more OFDM and OFDMA, but there's no more OFDMA because it's still a 3-1 split. It's a 204 upstream, right?
Correct.
So the modems out today support 2 blocks. That'll fit in the 204. There's no need for more blocks, from the modem. So that's not going to change. But the downstream, we have some usage. We're not saying, hey, let's go to 1.8 or even 1.2. We're saying you got spectrum. You might be able to utilize that spectrum more efficiently. So can we just put more downstream blocks in there? And we can, but the modems on the market can only lock on to 2 at a time.
Which is a problem.
Yeah, so I can get more per modem speed if I just put a chipset in there that could decode multiple blocks. So that's where we said it would be nice to have 3.1, just a little bit, not 4.0 FDX fighting against ESD. Let's have a modem be able to support decoding multiple downstream blocks.
Which could be a DOCSIS 4.0 chipset modem,
True.
or it could be a DOCSIS 3.1 plus, 3.1 extended, whatever that chipset is. It just has to be in a little bit more than the existing 3.1 modem, because it has to be able to lock to those additional OFDM blocks so we can extend that capacity.
It's almost too bad. There's more to it, I'm sure, but it's almost too bad. Like how you could change your RAM out of your
no kidding.
card.
If these weren't field upgradable.
Yeah, the chipset, you just plug it in, plug and play.
That would be the nice way to do it.
But I think in that regard, that's why I think we're seeing modems being split from the Wi-Fi router too.
Absolutely. Right? Yeah, we talked about that in our last episode, how operator vendors were looking at pulling out the Wi-Fi from the access point from the modem itself to reduce cost, reduce complexity, and a number of reasons.
Time delay of chipsets.
Yes.
Technology differences. Yeah.
So I'd love to hear from our listeners. Drop us in a chat room. Like, what are your plans? What are you seeing that you're doing? Are you going to stick with DOCSIS 3.1 plus or 3.1 extended? Or are you guys looking at going to 4.0? I'd love to know what's going on in your own operations. So from this, John, we've talked a lot about estimating OFDM, OFDMA capacity. That there's Cable Labs has models. There's been documents out there, and but there's not been really any easily accessible way of for people to estimate OFDM or OFDMA capacity without like having access to cable labs or things like that. So
there's no app for your phone.
Exactly. Not yet. So what I did is I thought we'd take this time to go through. I took a paper, and we'll go through that paper. I put some code together, and I made this publicly available on a GitHub page so that people can download it's a Python script. It's super easy to use so that everyone has accessibility to accurately estimate OFDM and OFDMA capacity for their own networks, whether they want to do this in as a cable operator, or if they just want to do this as their own, or maybe they want to develop an app for our industry. So, I mean, that'd be a great thing because lots of opportunities there. So today we're going to be talking about estimating exactly that and the code behind it. And where this starts off from is Karthik Sunderson. He's a principal architect. I don't know if maybe his title's changed at Cable Labs. Super smart guy, great guy. I've worked with him for a long time. I think it was 2017, he wrote a paper for SCTE Cable Tech Expo on accurately estimating DOCSIS 3.1 channel capacity. And I've been relying on this paper for a long time to, just basically do back of the napkin estimates. He actually has some really nice charts in there where you can say, given modulation, given bandwidth, here's my estimated capacity. And that's kind of the way I've been doing it. However, I was able to take his paper and pull all the math out of that paper and put it together and create a Python script for OFDM and OFDMA that, follows all the work that Karthik did, and now put that together so that we can basically say, let's put in the numbers, let's put in the bandwidth, let's put in the cyclic prefix, let's, basically any variable that we want, and say, what is our downstream capacity, what is our upstream capacity? And these can be building blocks for anyone now to take this and build their own models internally. But
what year was that paper?
That was a 2017 that Karthik put that paper, and anyone can find that on nctatechnicalpapers.com. Download that paper if you want to see all the details in there. Also I can't remember if I linked to that paper in the show notes or not, but I'll be sure to do that afterwards. So that link is also in there. I do have a link to my GitHub page that I put up, so folks can access my GitHub page and download the code immediately once they see this show. But I kind of wanted to go into why it's so hard. We can estimate the capacity of an SC-QAM channel really easy, right? We know that it's for 256 QAM, that's 37 megabits per second net traffic throughput for a 6 megahertz SC-QAM channel. If it's running at 64 QAM, that's about 27 megabits per second. I think these are like pretty much the industry standards of net traffic throughput for an SC-QAM channel. And they're fixed. They don't change unless, there's too many uncorrectable code word errors, and then there's either traffic going through or not traffic going through.
But it's the same modulation across the whole channel width, right?
Exactly. It doesn't change with impairments coming in and out. So SC-QAM is really simple, and you don't have a lot of variables to change in there either. It's either 64 QAM or 256 QAM. Yes, we can change some other things like interleaving and stuff like that, but we generally don't. We leave those fixed. We don't mess with any of that stuff. With OFDM, there's a lot of other variables, and in fact, there's about 12 different variables in the downstream with OFDM that we can adjust to optimize that OFDM channel. Things like, the bandwidth, the occupied spectrum, is it 192 megahertz in bandwidth, or is it 96 megahertz in bandwidth, or even smaller? There's what we call, band edges or guard bands that we have to leave so much bandwidth on either side before we put a channel. The actual modulation orders. And we know with OFDM channels, we can have different modulation orders depending on what impairments are within that channel. And there's about 12, I'm showing them on the screen here, there's about 12 different variables that can go into properly configuring an OFDM channel. And something just like the cyclic prefix, which is over on the right-hand side, that's a variable that some cable operators may use, or some cable operators may just leave fixed as the default in the CMTS. But the cyclic prefix, that will impact the amount of data that can go through the OFDM channel, but it will also impact the resiliency of the OFDM channel.
Trade-off, right? I could
Exactly.
have features on that or make it more robust to certain types of impairments, but that creates overhead.
Correct.
And that overhead amount can be dictated by my subcarrier spacing as well. Like,
Correct.
I could have a certain amount of subcarriers that will always be overhead, but if I have more subcarriers, then that percentage might be less when you do the math. And when I say that, like, if I do 25 kilohertz subcarrier spacing, I could have 8,000 subcarriers, but maybe there's a fixed amount of subcarriers that are always going to be part of my overhead. So yeah, there's a lot of the cyclic prefix or cyclic prefix. I hear the same terminology like QAM and QAM.
Tomato. It all depends. We're all friends at the end of the day. Who's going to fight over it?
This prefix, it can have a huge impact. I mean, I've seen the downstream with default settings, 192 megahertz wide only, and you're going to do some math. It might only get you, say, 1.6 gigabit per second. Whereas if I really optimize it, I can get 1.9 something, close
Correct.
to 2 gig, per 192 megahertz block.
Yep. And so part, what I'm hoping is, that part, now that this model is available, and I know a lot of people may have access to these models, but I wanted to make these models available to everyone so that they can start, and please like and subscribe if this is valuable to you. I want to make these models available to everyone so that they can start playing with these different features that are in OFDM and also OFDMA, so you can say, well, what are the trade-offs? Maybe I have a really clean downstream. I can adjust my cyclic prefix to get more capacity because I could already be at maximum capacity. So there's opportunities here for us to model our OFDM channel and just see what can happen with these different variables that we have. So we can take these variables. And we'll see this in the code. But when you download that from GitHub, all these variables are put into the code itself. I have some of the variables. I say these are your easily user definable variables, like your occupied spectrum, 192 megahertz bandwidth for your OFDM channel. I did put a lower band edge here, so and this is really not necessary to actually compute the actual capacity. Your lower band edge is just saying that you start at 678 megahertz. I don't want to do that now. Oh no, why is it doing that? It always does that stuff when you don't want it to. So the lower band edge would just be saying that you're starting at 678 megahertz. So that's kind of it's a building. I'm leaving that in there now because I'm putting the building blocks later so that we can start adding more OFDM channels. You could say I have 4 OFDM channels. What is my total capacity once I add those additional channels in? We have the average modulation order. So right now I've only built this out to support one modulation order, which is 12 bits. So if you if you did 2 to the power of 12, that would give you 4096 QAM modulation. So I don't actually have the exact modulation order in here. I'm just showing you the modulation order in 2 to the power 2's complement. So 2 to the power of 12 would give you 4096 QAM. 2 to the power of 10 would give you 1024 QAM, for example.
Yeah, you're going to have to either have a little decoder or some embedded decoder, right? And then people could select 1K QAM, 4K QAM, and then it puts 12 in for 4K QAM.
Correct.
And that's a bits per symbol.
Yeah, and actually shortly you're going to see that we've already had one contributor to this page, and you'll see that one of the contributors actually did that and made it a little bit more simpler for us. So these are the ones, your excluded band, your guard band, subcarrier spacing, 50 kilohertz, and then I had some constants down here because I thought the people that first start using this may not want to change things like the cyclic prefix, where we already said, hey, that cyclic prefix, you're going to trade off capacity for robustness in your OFDM channel. So some users may want to say, hey, I'm going to move my cyclic prefix up into the user definable variables because they may want to adjust that. So these are things that this is the first version of this I'm putting out there, and it's going to continuously evolve over time, and hopefully some other people will join in and also contribute to this model and evolve it to, again, maybe we'll add additional OFDM blocks, add a UI to this, and see how it can get better. But ultimately the proof is in the pudding, or the proof is in the bread, or whatever.
The proof of the alcohol is related to.
There you go. So to run this script is super easy. You just type, it is a Python-based script, so you can type Python or Python 3, depending on how you have your system configured. The name of the script is just OFDM_estimation.py, and then it's going to take those variables that you have configured in that previous screen that I showed you. It gives you the total bit rate, the rate across the whole channel. So this is really what we're interested in. That 192 megahertz channel that I had shown in the previous screen with all those settings that we had in there, there's 12 different configurable settings for the OFDM channel, has a total capacity at 4096 QAM, that 2 to the 12th bits that I had. It's going to give us about 1.68 or 1.6787, there's too many significant digits here, gigabits per second. So that's what total capacity one OFDM channel has operating at 192 megahertz of bandwidth if it was running at 4096 QAM, pure 4096 QAM. And then I wanted to verify, okay, was my model accurately matching what Karthik's Expo paper was? And this graph comes out of Karthik's Expo paper. So Karthik says if we're running at 12 bits for 4096 QAM here, that gives you roughly between 1.6 and 1.8 gigabits per second. And if we kind of estimate it in here, it's right around 1.65, 1.6, or maybe 1.67, somewhere around there. And so if we look up here, that's very, very close to my answers, as close as we can eyeball it. I'm getting 1.67. He's somewhere around 1.6, 1.67 in here for, again, 4096 QAM at 192 megahertz channel. So that's kind of what I wanted to see. What I find interesting is also part of this computation is I'm estimating the downstream phi efficiency. So if you remember, we ran this putting in 12 bits, and we're actually saying, well, we don't actually get 12 bits per hertz out of that. We're only getting about 8.7. So why is that? John, why do you think we're not getting 12 bits across the entire channel?
And now I was going to do it. You're basically saying, all right, here's 192 million symbols per second, megahertz, if you will.
Yep.
And what's our speed? So you can do some simple math, say, well, we're obviously only getting 8 bits per symbol if we're only getting 1.6 gigabit per second. So we know that we have all the overhead. So 192 is not what we really use. If it's 2 megahertz of total guard band, maybe 1 megahertz on each side. It could be 2 megahertz on each side. Let's say it's 1 megahertz on each side. That's 190 megahertz of actual bandwidth that's being used. But inside of there's overhead. We already talked about the PLC and the LDPC, the cyclic prefix.
Guard bands.
Guard band, So there's all kinds of stuff in there, and we know that. And there might be some that's actually used, but it's at a lower modulation.
Right.
Like the PLC.
The PLC is so I think in a previous slide we said that the PLC was set to NCPs are set to 2 to the 6 power for modulation. PLC, I know that is set in here at a modulation of where is it? I think
it's in there because it's probably hard set.
It is hard set, but I know that's set. We're going to see what the modulation is of the PLC shortly, but I know it's set to 64 QAM.
You have those pilots or the
QPSK, so they're a very low modulation.
And some are BPSK or something.
Yes.
And some are really, really robust, but we're not using those for data, so that's overhead as well.
Correct. So all of that takes away from or eats into our 192 megahertz of bandwidth and takes away capacity. And so even though we're saying it's 12 bits per hertz, it dwindles this down to 8.7 bits per hertz is what we saw in the actual downstream PHY efficiency results. So if we go to the next slide here, and I want to say thanks to SNMP Stack. So he was actually our first contributor to the code. What he did was he took the Python code and he recontributed back into the GitHub page as a combination of HTML and JavaScript. And he made us a nice page which is a little more UI friendly, where now you can plug in your occupied spectrum of 192 megahertz, your guard band, an exclusion band if you want, subcarrier spacing of 50 kilohertz. And if you remember before, we were plugging in 12 bits per hertz or 12 bits for 4096 QAM. He gave us a nice lookup table, so you can just click drop down and click your modulation directly as 4096 QAM, your cyclic prefix, the roll-off period, your modulation for your NCP of 64 QAM, interleave, pilot scatter factor, and then you can just click recalculate, and here we see again. So these are all the settings that I had in a Python program or Python script using at SNMPs, and thank you at SNMP Stack for contributing this. We see we're back to that 1.679. So he did a little rounding now. We don't have as many significant digits either. We're back to that same number, 1.697 gigabits per second for a 192 megahertz OFDM channel using these parameters up here. Now, let's say we wanted to change the bandwidth. Instead of 192 megahertz, let's drop that down to a 50 megahertz occupied spectrum for our OFDM channel. And we can see that we drop down to 395 megabits per second, or 0.395 gigabits per second for a 50 megahertz OFDM channel. So this is, again, just the UI version's a little more user-friendly, but has all the same attributes of the Python. So this is open to anyone now to have access to either the HTML version here, and to use the HTML version, you just download this from my GitHub page, double click on this OFDM.html file, and this will open up and run directly in any browser on your computer locally, and you have all these different settings to play with to test different different speeds, different things. So you could change the cyclic prefix and see what different cyclic prefixes, how that impacts your speed. Now, you're not going to be able to see how that impacts your robustness. That's something you're going to actually have to test in a live plant. So getting the code, obviously you go to the GitHub page. You'll see there's a README file that gives you some information on there. This is the HTML version of the OFDMA file. There's an OFDM, this is the Python version, and then I also have an OFDMA version, but I'm gonna leave that up for viewers to go ahead and run the OFDMA version. It's very similar to the OFDM version that allows you to estimate OFDMA capacity the same way that we just did OFDM capacity. So this code is not just theoretical. It's, you can use it to simulate your own plant and see how that capacity is going to build for any different size channels. But really, ideally here, we want to use this. If you're looking at DOCSIS 3.1 extended or DOCSIS 3.1 plus, we want to start thinking about how we're going to build out capacity into the future with multiple OFDM channels in varying bandwidths and things like that. So a lot of opportunities there.
So I have a philosophical question for you, and that would be, let's suppose you have an OFDM block and you have adjacent carrier interference. It's causing low MER at the top end of your block. And you know that if you increase your cyclic prefix, that maybe that MER for that very end, and maybe it's from roll-off or whatever, it could be roll-off or adjacent carrier interference, and you increase your cyclic prefix and the MER gets better. But you also know that your profile management is dictated by MER readings. And you don't want your entire block to change just because a few outliers are bad. So do you allow it to change the whole block, or do you use PMA or something that can design a more appropriate mod profile or profile just for that customer? Normally, your cyclic prefix is kind of hard set at a phi level, so it's not something that's going to change with a profile management. But you could change the modulation of those last couple bad MERs of the last couple of subcarriers and not change the whole block. You know what I'm saying? So it kind of goes, I look at it two ways. If I don't have PMA, I don't have that complexity of PMA, which is profile management
application.
Yep. If I don't have that and I have hard set mod profiles that are 4K QAM, 2K QAM, 1K QAM, 4K QAM across the whole bandwidth, it might behoove me to set a more of a cyclic prefix so it's more robust and I can run a higher modulation.
Yeah, no, I think you described it precisely. If you don't have PMA, and a lot of operators today don't have PMA, then making your cyclic prefix very robust is the right way to go, because then
it's a trade-off.
It's right? Well, yeah, I mean, you're going to make your cyclic prefix. You're going to make your cyclic prefix more robust, but at the trade-off of losing capacity. But True. That capacity trade-off is worth it, because you're going to have more DOCSIS 3.1 modems locking onto your OFDM channel, which means, yeah, and that's what we want, because then you're going to be taking capacity off of your SC-QAM channels and freeing up that capacity for your DOCSIS 3.0 modems. So that's the big opportunity there is, and most operators today still have a large quantity of DOCSIS 3.0 modems that are utilizing SC-QAMs, and those SC-QAMs are absolutely saturated. So we want to make sure the DOCSIS 3.1 modems stay locked to the OFDM channel. We can do that by basically increasing that cyclic prefix and making it do that. Now, that is kind of like a hammer. It's like, doing the cyclic prefix kind of is a hammer. Using PMA, that's much more surgical, a much better way of coming in, and now we can back off our cyclic prefix. We can regain the potential capacity that the OFDM channel has, and we can go in very surgically and fine-tune profiles based on different sections of the plant that, to your point, you may have an amplifier that has excessive roll-off. So in that section of the plant, we can optimize the OFDM channel to make sure those subscribers have a good quality of experience, whereas the rest of the network that doesn't have that roll-off just has really high throughput. So everyone's still on, everyone's still happy. We have a question here from Grab a Sandwich. Good to see you back, Grab a Sandwich. We've been having a lot of conversations. He says, this might sound dumb. The only dumb question is one that's not asked. I says, but it's still a struggle sometimes to figure out if something is service affecting or just reducing capacity / robustness, especially if levels look perfect, but he's saying nimble, but so the PNM application still shows issues. And he goes on to say, so I guess my question is, what do I look for? Code words, etc. Those numbers are still a mystery to me. So if we're talking about an OFD in particular, since we're talking about OFDM, I'm going to kind of constrain your question to that, Grab a Sandwich. If we're looking at OFDM, I agree, it's really tough when you look at an OFDM channel and it's, what's happening is the modem's bouncing between profiles. So we're going to show that one of those profiles, we're going to show multiple things. We're going to show that MER or RX MER per subcarrier is low. We're going to show a couple of those profiles. If you have 4 profiles, we may show that 3 of those profiles are disabled, but the lowest profile, like profile 0 or profile A, is still enabled. We could even show that that profile is taking some very small uncorrectable code word errors. The challenge is like, what do we do? Do we, how do we fix this subscriber that has a couple of profiles disabled and low RxMER? Like, do we run to that subscriber's house or do something? And do something, or do we wait? It really probably depends. If the subscriber has a gig tier speeds or maybe 500 megabit per second speeds and they're a DOCSIS 3.1 modem, then yeah, we probably want to do something sooner than later, because if their high level profiles, their 4096 QAM profiles are no longer usable by that modem, then that subscriber is going to have difficulties getting gigabit speed tiers. If that subscriber has really low speed, if they're like a low speed tier subscriber, like they're getting 25 megabits per second, then you could probably deprioritize and say it's not as critical that we rush to that subscriber's house and do something. So I guess that's where you really have to say, well, how do I prioritize this subscriber? And I think that's really where I would look to from an OFDM RxMER perspective on that subscriber. John, you have thoughts on that?
I guess not flip side, but as to exacerbate the problem, he might get the speed he's paying for, but he's using a lower modulation to do it. That means he's eating up more time on the wire than what he normally would, which is affecting everybody else.
Right.
So, so your block might have been, if everyone's efficient and everyone's doing their thing, your block might be at 50% usage because everyone's very efficient. Now you get this one guy that drops from 4K QAM down to 512 to get the same things he wants to do on his computer. He takes up more time on the wire to do it. He's getting his speeds because it's there, but now you're at 85% utilization. And then you're thinking, oh man, do I need to do a node split?
You're slowing everyone down on the node now.
Yeah. It's like, no, I don't have to do a node split. I got to clean up the guy that's actually taking too much time. He's not very efficient. So P&M stands for proactive network maintenance. But it's proactive. So P&M is there to tell you something's not running efficiently.
Yes.
It might not be a problem, but I mean, if I'm showing uncorrectable FEC code words, that's drop packets.
Yes.
That's drop packets. So yeah, but if P&M or PMA or profile management is locked on to code word errors to change modulation, it's self-healing. That's the whole purpose of OFDM and DOCSIS 3.1 is I see a problem. Yes, I'm dropping packets. It's affecting my quality, and I drop the modulation, which in turn affects my capacity.
Now, but I think you bring up an interesting point about P&M, because so when I started in the P&M journey, I was like, we got to be proactive. We got to be proactive. As I've gone through the P&M journey, it's like, well, as an industry, we're really using P&M reactively, because as an industry, we're really good at fighting fires. So why not use P&M to be reactive? But what I've seen is many industry leaders saying, to be successful with DOCSIS 3.1 and DOCSIS 4.0, we're going to have to be more proactive. And to your point, John, I think you really raised the awareness of why with an OFDM and also an OFDMA channel, being reactive all the time is really going to penalize us as an industry, because if we're always just waiting for the lowest common denominator, all of the modems that are dragging down the OFDM and the OFDMA channels, that's going to impact all subscribers. It's kind of like saying, okay, we're not going to worry about return path noise until all subscribers go offline. That would not be an acceptable way to combat return path noise. We know we have to constantly battle return path noise, or eventually all subscribers will go offline. And I think we have to look at OFDM and OFDMA capacity the same way, that we kind of have to be proactive about it, that we got to keep subscribers at a reasonably high order modulation or have PMA constantly running to ensure subscribers are kept up there. Otherwise, to your point, you can have a few subscribers that kind of keep that whole channel capacity low.
Yeah, they're using up more than they should. And I brought it up before. I thought a good patent idea would have been when a modem's not running at its highest capability, only allowed to have a quality of service maybe half of what its current capacity is.
Like kind of throttle them a little bit.
So it's running at 512 QAM, and I know at that modulation with this much bandwidth, the pipe for him alone would be worth 1 gig. Well, if he signed up for 1 gig service, I'm going to drop them to 500 megabits per second, half of that, because I really don't think people should be provisioning more than half of what the aggregate is. But
Right.
the aggregate is changing all the time, right? So that's what I'm saying is, if the aggregate is small because I'm inefficient, I'm lower modulation, I thought that would have been cool. Like when I was at Cisco, we also had something called STM, Subscriber Traffic Management. Once you went over a certain amount of bytes of usage over a certain amount of time, it would drop your costs,
Right.
like slow you down.
So throttling, fair
The same
usage,
idea, right?
depending on what you want to call it.
Yeah, throttle you down. The way they got away from lawsuits is they said we're throttling you down based on bytes. That's nothing. There's no bias there, right? It's
Yep.
not over the top video. It's not this, that, gaming. It's bytes.
Just
Could
raw
be email,
data.
bytes are bytes.
Yep. Yeah, no, that totally makes sense. So, Grab a Sandwich says, thank you. I'd be interested to see what you think about diagnostic screens we access to check RF levels, etc. It's a lot to absorb. I agree. There's so much data out there. So he so totally supports the reactively. He also says, I don't think my ISP MSO has the manpower to be proactive. And Grab a Sandwich, we hear that a lot, that, you know, being proactive is really it is a difficult thing to do, and so that's why I said that we see a lot of our customers using a P&M application in a reactive manner, which that's what I said when I started this journey. It's like, oh, we got to be proactive, but the reality is we're in an industry that is very good at being reactive. So
yeah, firefighting. It's
we're
by
good
the
at
way, his what do you call it? The avatar. Does that say mighty and us?
I think
and us?
yes, and us. I think that's what it says.
All right. Good
call on that one, John. I'm glad you read that and not me.
Nothing gets by me.
You're sharp as a tack, my friend.
Nothing goes over my head. I will catch it.
So, John, I think that about wraps us up today. That was a good coverage on OFDM, and I think that kind of helps people understand why calculating OFDM is not so straightforward. John, you have anything coming up soon? You traveling anywhere?
Yeah, I think the winter conference is coming up in Orlando.
I'm going to see you there. I'll be there with you as well.
March 26 and 27, right?
Yes, sir.
So I plan to be there those 2 days.
If any of you from our audience will be there, please do look John and I up. We'd love to see you. Cars says he's an ISP engineer. And he says, I can confirm we don't have the manpower to be proactive either.
I think that just goes for everybody. I mean, everyone's running thin, right?
Yes.
And then it's just like myself, a lot of older cable guys are retiring. So you're not just losing manpower, but you're losing intellectual property, like IP, like the background that people had in the industry.
Yep. So Grandpa Sandwich says, thanks again, guys. Cars folded creatively. So, all right. So, John, we will see you at definitely see you at Cable Labs Winter Conference. Hope to see some of our viewers there. A huge thanks, John. Nice seeing your hair. Thanks for your comments today. Insights were greatly appreciated. Thanks for everyone on the chat board. If you didn't get your questions in today, please do drop them in our chat or in our show notes below. We'll get them out there. Please do like and subscribe. We greatly appreciate that. We will be back on April 5th with Mike Odell. He's going to join us. The topic will be a new topic for us, so be sure to catch that show. And other than that, thanks everyone for joining. Tune in again and take care all. See you later.
See ya.